Imagine controlling your web application with just a wave of your hand. No clicks, no keyboard, just the pure gesture control magic. Today we will build this using Tensorflow.js, and trust me, it's easier than you think. So let's get started. Hey developers, I'm Stefan from Stream, and today we'll be diving into the world of machine learning on the web. We'll be building a gesture detection system that you can integrate into any web application. To demonstrate the simplicity and versatility of it, we will use raw HTML and JavaScript to build up the demo, and to give it a real-world spin towards the end, I'll show you how you can integrate this into a real-world, production-ready React application. So stay until the end to see this. Before we start with the implementation, I want to quickly touch upon the why are we actually doing this. In recent years, big models from big providers such as GPT-4o have become really popular and powerful. However, they require a lot of resources to be running. Another trend, however, is that smaller models have become more and more powerful, and we can actually run some of them in the browser directly. So this is exactly what we want to do today. So I want to demonstrate that this can be enough to build cool functionality into your web applications. So without further ado, let's get started with the implementation. To keep things clean and straightforward, we'll build this project without any dependencies on any frameworks. If you're interested in learning how to integrate Tensorflow.js into a framework, then please let me know in the comments what I should build. Of course, the basic building blocks of a web application are a package.json file, an index.html, and a index.javascript file. Naming is optional, but these are the ones we need. So to get things started, let's jump into the terminal here and get started with a new project. And I have created a new folder that is empty at the moment, as you can see here. And we can now say npm init -y. The -y here is answering all the questions that we would get from npm to set it up. And since this has already successfully happened, we will now jump into VS Code, which has opened up here. We first create two files, an empty index.js file that we will take care of in a second, and another new file called index.html. Here we can use the exclamation point, which is an Emmet abbreviation, and will automatically create a HTML file for us that has the skeleton that we need. We can change the title to something like gesture detection. And with that, the head tag is done. We can now add something to the body, something like a heading called gesture detection as well. And we need to integrate the script here. And as the source, we want to say we want to have the index.js, and we close the script tag. So with that, upon loading the web page, the index.js file is triggered and loaded. So that's enough for us for now. And the final step we need to take is we need to execute this to show this in the browser somehow. For that to work, we could either set this up inside the package.json, or we can use a handy extension called Live Server, which is developed by Ritwig Day and is very popular, as you can see. I have installed this already, so the convenient thing I can do is just tap on Go Live here, and it says server is started at port 5500. So let's switch to the browser and open up a new tab and go to 5500, and we can see the gesture detection headline is showing up. So the project setup clearly worked, and we can now start with actual implementation. Before we get started with implementing logic, we first set up the HTML structure and load some dependencies to get started. So we jump back into VS Code and open up the index.html file. The first thing we do is we add some scripts to load packages that we want to use inside the project. The first one is called Fingerpose, and it is a JavaScript library that detects the actual poses that we want to do with our fingers that are detected through a Tensorflow.js model. Speaking of Tensorflow.js, we add three dependencies here. The first is to tfcore.js, so the core package. Then we need the converter package, and finally a tf backend. We choose the WebGL one, which is recommended, but there's also a WASM option. To be honest, I'm not entirely sure how much different the two are. In my comparisons, they were very much the same. But I can imagine that for some use cases, the performance might vary. Finally, we add a dependency to the Handpose.js package because we want to visualize a little bit how this model sees our hand and how we can use that to detect gestures. With that, we have loaded all the packages that we need. So let's add some HTML structure to this. And first we start off by adding a div that is a container div. We give it the idea of video container. And inside we add a canvas element that we will use to draw onto. And then a video element that demonstrates how to get input from the webcam. And lastly, we will add a gesture text headline component that will visualize which current gesture we're detecting. So this is all the HTML elements that we need. So let's add some slight styling here with the style tag in the header. And first, for the video container, we want to give it a position of relative. The webcam has a position of absolute and will be hidden because everything we will be showing will be drawn directly onto the canvas element. Lastly, we will give the gesture text an absolute position, putting it to the bottom right of the video container and giving it a larger font size so that it's clearly visible. With that, all the HTML we need is there. And to celebrate, we will take a sip of coffee. All right, with that done, let's get started with implementing the logic. Next up, we want to retrieve and display the stream of the webcam on our page. So we switch from the index.html to the index.js file and get started. We add a few helper functions first. The first one we call load webcam, which defines a width and a height as well as a frames per second parameter. And first we check if we have access to the media devices, specifically the get user media one, because that's what we need to retrieve the webcam image. Then we take the video element that we have given the webcam ID and we say it's muted and we give it the width and the height that we got as a parameter here. Then we add a media config. We're currently not interested in audio, so we set this to false. And then for video, we want a facing mode of user, because that's the user-facing camera for mobile phones, for exactly. Give it the same width and height than we gave to the video element and set a max frame rate of FPS, which is the last parameter we get. Then we want to get the stream of the get user media with the media config element that we just defined. Set this stream to the video.source object. And finally, we turn a promise where we wait for video to have loaded all the data and then resolve the video and return this from our load webcam function. Next, we add another helper function called load video that basically just takes the load webcam function, has this as video, takes this from a config object that we will define in a second, and then says video.play. So we want to display the video and return this. Next, we define the config object that I just set. We set this to a width of 640 by 480 with a frame rate of 30 frames per second. The reason to choose this is that it works really well with the hand tracking project. Then we also have global variables for the video width, height, as well as the drawing context that will become interesting in just a second. With that in place, we will now add a main function that we will call when the script gets loaded. And here we first load the video. So we call the function we just defined. And with the video element present, we will take the width and height and assign it to the global variables that we just defined. We will extract the canvas element by the ID from our document. So this is the HTML canvas object, and set this to the same width and height as the video element. And then we define a drawing context. And this is the object that we will draw everything into. So not only the video, but then later also the different elements of the hand that we will see in a second. So we take this context in a 2D space and then clear the rect. So we basically omit everything that is part of the drawing context to make this empty. We then set a few properties here. So the fill style will be white. So everything we draw here will be white by default. We translate the width and we scale everything slightly. So basically what we're doing is mirroring the video horizontally so that it looks more natural to the end user. With that, the canvas is ready, but we actually won't see anything. So finally, let's draw an image into this. We will use the drawing context.drawImage function, hand in the video as well as the remaining parameters. And if we save, we can now switch to the browser to see how this looks. Well, this is a very flattering image of myself. Thumbs up for that. But you can see it's not moving. If I reload, it will take the first image, will draw it onto the canvas, but it will not continuously update. But at least we see that the webcam image is captured. We see that we can draw this image onto our canvas, because if we inspect this, we will see that this is actually the canvas element and not the video one. But we see it works. We can draw onto the canvas that we defined. And with that, we are ready with this portion. And now we can think about how we can actually extract the hand gestures as well as continuously display the video stream. So let's jump on to the next chapter. Next up, we want to detect and draw the landmarks of a hand. And for that, we jump back into our index.js file. First, we will add two helper functions to actually draw onto our canvas. The first function will be called drawPoint, and it will do exactly that. So it will start to draw a path, draw an arc to a point, and then fill this context. Next, we also want to be able to draw a path with some points, the closed path and the color. For that, we select a stroke style with the set color, create a new region or a path, and then we move to all the points that are inside of our points array and draw respective lines to each of them. And then if the path should be closed, we close it, and otherwise we just do a stroke with the region that we have defined above. With that done, we will add a few more variables that we need. The first one being a model, which we will use in a second, but this is basically the machine learning model used to detect the hand itself. Then we will create an object which is called finger lookup indices, and it contains all the different fingers, so the thumb, the index finger, the middle finger, the ring finger, and the pinky finger. And it will basically display all the different joints or all the different landmark points that the model detects for each hand. We will see how this looks in a second. And then to draw each finger in a different color, we will set some landmark colors, which simply goes over all the fingers that we have, as well as the palm base, and assigns a unique color to them so that we can draw them in different forms. Speaking of drawing, we add a draw key points function, which is doing exactly that. So it will make use of the helper functions we defined and the finger lookup indices and landmark colors to actually draw the key points of a hand. So for all the key points that we have, we extract the y and x variables and draw the point. And then for each of the fingers inside of the lookup indices, we iterate over them, extract the finger, extract the points through the lookup indices, and then draw a path from each point of the finger, so each joint we move along. Again, this was another helper function, so let's get into the nitty-gritty here. So we add a new function here which says continuously detect landmarks. I mentioned that before we only were drawing the initial image for the webcam, so now we want to do this continuously. And we will create an inner function here called runDetection that we will loop over. And first we use the same function to draw the image of the current webcam video stream. And then we will draw the landmarks, but for that we need to have the model to estimate the hands. So it has this estimate hands function that will get the video as an input, so the video stream, and it will give us some predictions. If this predictions array is not empty, so it would be empty, for example, if no hand was in the current scene. So if it's not empty, we start by extracting the landmarks and then drawing these key points into our canvas. Then we update this, or we continuously trigger this by requesting a new animation frame and running the runDetection function here. However, for the first time we call the continuously detect landmarks, we first need to load that model. Remember, we defined this object here at the top. So what we can do now is we can use the Handpose package to load this model initially. We do this only one time. And then we call the runDetection function, which will then trigger itself on every redraw. Of course, finally, we need to call this continuously detect landmarks function. And luckily, we can now also get rid of this because this will be called every time the runDetection function runs, which is on every redraw. So if we save this, we can now switch back to the browser and we should now see our camera feed in action. So you can already see that works. And if I now put up my hand, you will see it detects all the fingers and it draws lines for all the joints or all the landmark points that it sees for each of the fingers. It also works for the other hand. It will detect red for the thumb, the index finger. You see there's at times there's a slight offset, so it's not a perfect model, but I think it works decently fine. It can only detect one hand at the same time. So this is a limitation of this package, but I think the performance of it is quite nice. You can do either side. So I think it's quite a good result. We are quite happy with that. And seeing the pose that I'm currently making, wouldn't it be cool to detect this? This is what we will do in the next step. So far, we have used the Handpose package to determine the shape of the hand as well as the orientation of each of the fingers. However, we now want to detect the poses, and for that we will use the Fingerpose package. We already integrated this into the index.html file, so we're loading this already, so we can jump right into the implementation inside of our index.javascript file. First, we will add another variable here called gesture estimator that we will initialize in a second. And then we will scroll all the way down to the continuously detect landmarks, where we initialize the model for the hand pose. And here we add no new code, and specifically we first add known gestures. The FP is the finger point package. And it comes with two pre-built gestures, the victory gesture and the thumbs up gesture. So for that, we use these known gestures to then initialize the gesture estimator, which is again an object from the Fingerpose package, which we can initialize with the known gestures. With that, we can now say, after predicting and drawing the key points, we will now check again if the predictions.length is larger than 0 and we have the landmarks inside of our first prediction. If we have that, we use the gesture estimator to estimate which gesture it found. We can hand in the landmarks and we can add a confidence score between 0 and 10, with 10 being the highest. We can play around with that, and by setting it higher, it will only detect hands or gestures when it's really certain. And if we lower this, it will also detect them with lower confidence. So we use this estimation and say, if we found an actual gesture, we call the reduce function and sort everything to find the gesture with the highest match score. So it will also say, I found two gestures and we now want to have the result with the highest probability. And then we say, if the result.score is higher than 9.9, so if the model is really certain that this is the gesture that it expects, then we update the gesture text element, which we defined here, to have a text content of the gesture strings object that we will define in a second, together with the result.name. So lastly, let's define this gesture strings object. We scroll all the way up and we add this here. And it simply says, if we find the thumbs up gesture, let's use this emoji. And if we find the victory pose, then let's add this emoji. We save, and now we can take a look at whether everything works. So right now it doesn't detect anything, which makes sense. Now I have a hand, and if I do the thumbs up gesture, you see it shows up at the very right of my screen. So style-wise, I think we can do better. But if I do the victory gesture, it works. Thumbs up is detected, victory is detected. So it's really cool. It works quite good. So I think this is quite impressive. And I think we achieved what we wanted to achieve, basically. But now I would like to do one more thing and add a custom gesture, because this is just using the pre-built ones. And it's actually quite easy to define our own gestures. And to demonstrate this, we will use the thumbs down gesture to do this. So let's jump into the implementation there. Before we start with the implementation, let's first discuss how we can actually define our own gestures using the Fingerpose package. To define a new gesture, we can define for each of the fingers two things. The first one is the curl and the second is the direction. Speaking of the curl, is we for each finger, in this example the thumb, we can define whether it should have no curl, a half curl, or a full curl. And then for the direction, we can go basically through top right, top left, bottom right, bottom left, horizontal left, right. I think you get the idea. So in order to get our description of a gesture accurate, it is best to describe as much as possible. And we will now jump into the code to see how we do just that. We are in the index.javascript file, and let's define a function first, which will do the thumbs down gesture definition for us. We start off by creating a new thumbs down object, which uses the Fingerpose.gesture description object to define a thumbs down gesture. We will return this. Okay, so the first step is to say, okay, I want to add a curl. So if I do a thumbs down gesture, I'm sure that the finger, specifically the thumb, has no curl, because otherwise it wouldn't be a thumbs down. Now what we can do with the direction is two things. We can first say we want to have a vertical down of the thumb with a confidence of 1. So this is the highest confidence that we can define. But to make this a little bit more robust, we can also add other directions with specific probability values. So in our case, we will add another direction for the thumb again, saying a diagonal down left with 0.9 probability, and then a down right diagonal with the same probability. So if the thumbs down is not perfectly downwards, but more towards one of the sides, this will also work. And with that, we have just a little bit more robustness in our definition. Of course, we also need to define the other fingers. So for the index, middle ring, and pinky finger, we add a curl. So we say if it's either a full curl or a half curl, we are fine with that. So we set the probability to 0.9. And with that, we have definitions for all the fingers. And you can already see this gesture is quite easy, but we could go the same way for any other gesture that we want to define. And go through each finger and define the curl as well as the direction if we need it. So next, we will add a new gesture string to the gesture strings object, which is the thumbs down, displaying this emoji. And then finally, all we have to do is scroll all the way down to the known gestures. And here, together with the victory gesture and the thumbs up gesture, we can also add our own gesture with the function that we just defined. And that's all the code we need. So if I save and I can now jump back to the browser, we will see the result. It's still working. I can still do the thumbs up. It will show up. And now I can also do the thumbs down, which will work impressively well. So we can now jump back to the browser to see how this looks in action. I am still here. I can now do the thumbs up as usual. I can do the victory, but also I can do the thumbs down. And this will work just as well. So thumbs up, victory, and thumbs down. I think we've built something quite cool here, and it's quite easy to implement. It doesn't require much code. It can be integrated into a very basic HTML JavaScript project. But now, finally, we also want to demonstrate that it's actually quite easy to implement this in a production application with a React example of a video calling app, which we will jump into now. We will not go over the entire code for this React application, but just look at the most important parts to demonstrate how easy it is to integrate this functionality. If you're interested in the full demo of the project and the entire source code, let me know in the comments and I will add a link to a repository with that, or I might even make another video covering that. So let's jump into VS Code to quickly show you how this works in a React application. So first we can use the use camera state hook that the Stream SDK provides us to get access to the raw media stream of the call participant inside the video call. And then we first initialize the video object. We again define the known gestures that we have done similarly to before. We create a gesture estimator, load the Handpose package, and then set some properties on the current component. And then all we do is we run a loop which estimates the hands on each run. And with the predictions, we do the same thing that we've done before. We use the gesture estimator to estimate the current gesture. And if we detect one, we say if it's a victory gesture, we want to show confetti. If it is a thumbs up gesture, we unmute ourselves and then show a toast saying you are now unmuted. So let's jump into the browser to see how this looks. We switch over and we can now say, I want to show a victory sign. And you can see the confetti pouring down, which is just a very cool effect. And if I do a thumbs up gesture, we see the you are now unmuted toast showing up. And this now controls our entire video calling application using just our hands, which is quite cool, to be honest. With that, we have come to the end of this video. Let's quickly recap what we have achieved. We have integrated the Tensorflow.js package together with the Fingerpose and Handpose packages to achieve a gesture detection that runs only inside of our browser. Also, we have integrated a custom gesture and demonstrated how to integrate this powerful capability into a real-world React application. If you're interested to see more and maybe integrations into other frameworks, feel free to leave a comment below the video. And if you enjoyed this, feel free to like the video and subscribe to the channel. We'd highly appreciate that. Thank you for watching, and I hope to see you in the next video. Bye!